I'm recording. So, we've already used the substitution method. Now, this is an exercise in the book, just to show you. This is one. And basically it says, solve them using substitution, solve them by elimination. All right? So let's have a look at what we would do with the first one. All right, substitution method. So a few of you met one exactly like this yesterday. Yesterday or the day before. So y equals 2x plus 1, and number 2 is y equals negative x plus 7. All right. If we use substitution method for that, this is actually a really nice and easy one. It basically is substitution in that, well, this y and this y are the same thing. Therefore, this and this are the same thing. So really, I could replace this y with what this y equals. So it is just a substitution method, but you end up with a nice and simple one, which is just minus x plus 7 equals
2x plus 1.
2x plus 1. All right, and it makes sense, because if you think about what these look like, this would be a line going up like this would be a line coming down like that, where one line equals the other line is where they cross, right? So we know that with the graph. So how do we go about solving that one? First step?
Subtract 1.
Subtract 1, okay. Subtract 1 from both sides, I get negative x plus 6 equals 2x.
And then add x.
Then add x to both sides, gives me 6 equals 3x.
X equals 2.
Therefore x must equal 2. Is that the complete solution? How do you find the y value?
You have to substitute in 2.
Now, just to make something clear, that is what you do. You substitute that value of x. We've done that several times. You know it. I'm just not going to bother, so we can move on quickly, because that's substituting in whichever one you found into the equation. That does not change for either method. All right? So the two methods only change in that first, finding the first value, whether it's the x or y. Okay. All right. I'm going to go straight to C now. All right. And we're going to do substitution method. So write that down. So we've got number 1 is 6x is 20 minus 2y. Number 2 is y plus 3x minus 5 is equal to 0.
Agree.
What would you do first for this one? Which one would you rearrange?
Maybe.
Wait, so is this elimination or substitution?
This is still substitution.
I rearranged 2 because times plus 5.
I would go with rearranging number 2 because it's got one y. As soon as I identify it's got one of anything, one y or one x, it's nice and simple. I don't have to do any division. Why would rearranging number 1 be? Well, I could actually rearrange to make it y and then divide by 2, which would equal, that'd be fine. But if I divided this by 6, that would be a bit awkward, wouldn't it? So actually, number 1 could work with an extra couple of steps, but I'm going to choose to rearrange number 2, like Matthew said. Rearranging number 2 will give me, if I add 5 to both sides, that gives me y plus 3x equals 5. What do I do next?
Oh, wait, no.
And minus 3x.
Take away the 3x. Gives me y equals 5 minus 3x. Okay. Now what do I do? Substitute my new number 2 into number 1, right?
Yeah.
So this value of y gets replaced by
5 minus 3x.
5 minus 3x.
5.
Okay. So, sorry, I'm running out of space. I'm doing this quite quick. I am recording, but I'm doing it quite quick because we've had, what, 2 full lessons on this already? And so, you've had lots of chance to ask all your questions, but do feel free to stop if you need to. 20 minus 2 lots of brackets because there's 2 terms there. 5 minus 3x. Okay? So that y up there got replaced by the 5 minus 3x. And now we are at a stage where we can solve for x.
Sorry, just recap the brackets.
Yes, this is just recapping. So this would be 6x equals 20 minus 10 plus 6x, yes? 6x equals 20 minus 10 is 10 plus 6x. How about minusing 6x?
Crying hard. Divide by 6x. No.
No, we've done nothing wrong.
X equals 10. Wait, no. X equals.
We have talked about this, but you might not seen this result before, but we have talked about the possible options.
So elimination is better than this.
Right?
Does elimination look better than this?
Have we done anything wrong?
No.
Elimination method would give me exactly the same solution. Remember, elimination method and substitution method, although we haven't done elimination method, the job isn't to get a different answer. If we get a different answer using 2 different methods, something's wrong. One method is just maybe more efficient or easier for us to do at the time, but the solution should be the same. What? Have we done anything wrong? Let's just check. Did we rearrange number 2 correctly?
Yeah,
Did I write it down correctly?
I think so.
Yeah. I rearranged correctly. Did I substitute it into the correct one? I didn't substitute it into itself. No? No? All good? So we've got 0 equals 10. That'd be good, wouldn't it? If I've got $0 in my bank, that's the same as $10. Sorted. Doesn't work that way.
Doesn't 0 also equal like 20 then?
But
if you
not
have-
according to this.
If you have double the nothing.
What does this result mean?
In the lines intersect at 10 y, or the y intersects
Did you hear that?
Oh, okay, so.
They're
What
parallel.
did he say? They don't intersect.
They don't intersect, which means
They're parallel.
they're parallel, which means there is
So that is what you said.
no solution. We get this thing and we're like, what? That doesn't make sense. So there is no when we get this is an example. Now, is that correct? So do you remember we could look at 2 equations and say, we know they are not going to have a solution if what?
If what?
How do you know 2 lines are not going to intersect?
If the gradient is.
They have the same gradient. So should we rearrange these both into y equals mx plus c form? So number 1, by the way, if we rearrange that, if I add 2 y's and then subtract 6 x's, I get 2 y's is equal to 20 minus 6x, yeah? Happy with that? Did it 2 steps in one go? What would I do now? Divide by 2 gives you 1y equals
10 minus 3x.
10 minus 3x. What did this one end up being?
5
Y
minus 3x.
5 minus 3x.
So they have the same
So that they do, don't they? What is the gradient?
3x.
3. Do they start at
Negative
different values?
Yeah.
Yeah. So we know those two are not good. So that's an important one because at this stage we hadn't really got, we knew about it was potential that they weren't going to get a solution, right? But we didn't actually have one where it's like, oh, that's what it's going to look like. All right. Okay. So this one, remember how many solutions?
No.
A. 1 solution. This one is
None.
0 solutions. What do you think this one's going to be?
Oh yeah.
Infinite.
Yeah? Think that one's going to be an infinite number of solutions. Is that because it's the same equation?
No, I think it's just a process of elimination.
But is it the same equation?
No.
That's why it would have infinite number of solutions.
It's not.
Yeah, should we just have there 2y plus 8 equals x?
Oh yeah, it is.
4y minus 2x is negative 16.
It's the same
Are they basically the same
If you
equation?
subtract x and then multiply by 2, then yes.
Yes, subtract the x, subtract the 8, multiply it by 2, you get exactly the same thing, yeah? So number 1, number 2, if I rearrange number 1, so as David said, subtract the x, gives me 2 y's. If I subtract the x and I subtract the 8, I get 2y minus x equals
Negative 8
negative 8.
times 2.
And if I times it by 2, I get 4y's, negative 2 x's, minus 16. So that's the same line. All right, now we haven't looked at elimination method yet. So now we're going to look at elimination methods.
Using
Right?
the same systems.
Sorry, what do you mean same systems?
The same systems we used
Oh.
earlier.
No. Come on, give me a new page. Page.
Append.
So we're going to be looking at these ones. Right. Let's take. Which one should we do?
J.
J.
Or H.
No, I went to J. I am going. Well, let's start simple. Let's do B to start with. All right. Now, could we use elimination method here?
I don't know.
Probably.
No, sorry. Could we use substitution method
Yeah.
here?
Yeah.
Yeah, you know how to do it. Would it be a tricky one with fractions and stuff?
Yeah.
Yeah, because it'd be divide by 2 if you know, which would be 3 divided by 2, which is a.
1.5.
Yeah,
x.
this one would
We'll
be
have enough
divided by.
space to do it.
Pardon?
We'll have enough
I don't know. I don't know how big you're right. So we are going to do. This would prove. We could do it substitution method, but it would prove slightly difficult. All right, just with fractions and stuff. But my starting point remains the same. Okay, now, elimination method is actually normally the one we do first, but didn't do this time around. Now, what we try and do with elimination method is what we try and, it's called elimination method, because what we want to do is eliminate one of the variables as having an impact on the answer. So, for instance, 5x's minus 3y's has to equal 5. Alright? 3 of the same x's and 2 of the same y's has to equal 4. Now, if I just said to you, just on its own, 5x minus 3y has to equal 5, how many possibilities are there for x and y?
A lot.
Infinite. Because it's a line, and a line is a infinite number of points, therefore there are an infinite number of x and y's that can go together in that way and make the answer 5. Because there'd be lots of decimals and things, right? So we would have no way of knowing, just with the same with the substitution method, until we get a second piece of information. Alright? But at the moment that piece of information is equally confusing. We do have a way of sorting it out, but we're going to have a different way. Now I'm just going to do it, and let's see if you can figure out what I'm doing. Alright? So my elimination method is this.
He wants to write it.
Yeah, you can write it. But think about what I do, and without just writing it down, think about what I do. Now, I am going to do this. I am going to multiply, okay, the first one by 3. So my new number 1 becomes 15x's minus 9y's equals 15. Happy with that?
No.
My number 2, I am going to multiply by 5. So number 2 becomes 15x's plus 10y equals 20. Now, while you're writing that, just let me say, so I haven't eliminated anything off the page yet, but what I have done is I have now eliminated x as a cause for the change in the answer. Why have I done that?
Because they're the same.
Is that the same? If you look at it, look, if x and y is the same number, well this 15x and this 15x is exactly the same thing. The answers, though, are different, right? Equals 15 equals 20. Therefore, this change in the y from minus 9y's up to plus 10y's must be what caused the change in the answer. Must be. Does that make sense?
Yeah.
So I've eliminated x as a cause of the change of my equals in the answer. Right? Now, the actual word elimination also comes from, I'm now going to do, well, how do I work out mathematically the difference between two things? Subtract. So I am going to look at which way around, and I'm going to write down, I'm going to do equation 2, and I'm going to subtract equation 1 from it. Now, you could do it the other way around if that works. I've chosen this way round to subtract 1, because the answer will be 20 subtract 15 is 5. If I did 1 subtract 2, it would just become negative 5. Right? But I'm not writing that whole, when you did subtraction, you always write 9 subtract 5, and it has to be that way. I'm being a little bit more flexible here, and I'm going, well, I'm doing it that way instead. That's why I'm writing that, so I'm clear what I'm doing, and I don't get confused. That's clear to you why I'm writing it.
Yes.
That's where the ones, remember I said you get used to writing the 1s and 2s? This is why. What's 15x subtract 15x?
0.
Eliminated, right? So x's are no longer a factor. So this is what's important. What's 10y's subtract negative 9y's? 19y's.
Say that again?
10y's subtract negative 9y.
So you just add 9.
So maybe if I add, so that was 10y's subtract negative 9y's, and this is 20 subtract 15. Yeah? How do I finish it off? Well, y is obviously 5
over 19.
divided by 19. Am I finished?
No.
How do I find
You have
x?
to put it into the.
Substitute it in. Which one?
Find out.
Into y.
Any of them. Yeah. All right. Now that's elimination methods. How do you feel about elimination method compared to substitution?
I like it. Baller.
Right.
It looks pretty nice. Baller. Oh.
So a lot of people actually tend to always head towards elimination method.
Ready?
Wait,
Yeah.
Are we getting our calculators and the
Yeah.
exams?
Right. I am going to do F. Right, with you. I'm not going to find the second variable. Like I said, you can do that, right? You know how to do that. It doesn't change. Right, let's have a look. Let's do one more together. Now, let me ask you this. If you saw this question, which method would you think to use?
Elimination.
Either or.
Why either or?
Probably substitution.
Yeah, probably so.
Why substitution?
Because there's one x.
Yeah, it's this x. I can look at that and I go, that's a super easy substitution, isn't it? X equals 3y plus 5, chuck it in, done. Right? There's no multiplying each one, there's not. Right, so just to rattle through substitution method really quickly, it would be x.
X equals
X
3y.
equals
3y minus 5.
3y plus 5.
Oh, yeah.
Add the 3y.
Negative.
Number 2 would be 3 times 3y plus 5
No, he just changed it.
plus 2y equals 4. No, I've added 3 y's. Yeah, so that side. So 3y plus 5.
Oh,
Yeah. Substitute in, what do I get? 9y plus 15 plus 2y equals 4, which is 11y plus 15 equals 4. That's 11y. If I subtract the 15, gives me minus 11, which is y equals negative 1. All right,
Oh, I see.
substitution method. That one, nice and easy for substitution method. Let's have a quick look at the other method instead. Number 1, x minus 3y's equals 5. Number 2, 3x's plus 2y's equals 4. All right.
Multiply them by
Now this one with elimination, actually I'm only going to multiply one of them. Now, we don't have a lot of time. Tomorrow we'll talk about, I can actually, it's negative y's and positives. If I add a positive and a negative, I end up with nothing, right, as long as it's the same. So negative 3 plus positive 3. So there is a way of doing it. So I would, however, look at this one, and instead of multiplying by 2 and multiplying by 3, I am just going to multiply number 1 by 3. I don't need to multiply the second one at all. It's going to be, so number 1 becomes 3x minus 9y's equals 15. Number 2 is still 3x plus 2y's equals 4. Now what do you notice I've done that a lot of you wouldn't bother with? Writing it all out again. Some people are like, oh, but I've not done anything to 2, I'm just going to write number 1 again underneath. Why did I do this? Because it does get complicated. Lots of writing on the page, all right, and I want to keep a track clearly of what I'm doing. So I always, personally, other teachers might not bother. They might just write, oh, I'm going to rewrite number 1 underneath, and then that's fine. But I always rewrite my new number 1, and if number 2 is still the same, I still rewrite it.
How did you, Mr. Potts?
Yeah.
In the top right, how did you get 11y?
Yeah. So,
9y's plus 2y's.
but why
That's substitution
not
method.
subtract? Oh, yeah.
Yeah, just collected the like term. Elimination method though, I've made it so that the x values are the same, so they are going to be eliminated. I am this time, personally, I'm going to do number 1 subtract number 2. That's my choice because 15 subtract 4 is 11. Negative 9y's subtract positive 2y's makes negative 11y's. And therefore I end up with 1y must equal negative 1. Which is good news, because that's what I got for that answer. So I get the same answer using that elimination.
Alright.
Okay? Right, there is lots more to talk about with the elimination method, with what the options are, but I'm going to let you have a bit of a practice. So, some of these questions, it'd be interesting to know what you think. Well, what happens with E, for instance? What happens with when they're a bit mixed up? What are you going to do, even for elimination method? So the ones that I've done have been lined up very nicely, that the X's and Y's lined up, the X's and Y's lined up. But this one, for instance, is not lined up. So it'd be interesting to know what you decide to do. All right? But have a go. I've got a couple of them, if you can, at least one of them. Well, a couple of them I would like to go through very quickly. So this one, I think you've been discovering that if we do this one, look.
You die.
You might. Number 1, look, guys, pay attention. 6x plus 9y is equal to 12. Number 2 is negative 4x minus 6y, negative 8. Now, this leads me to a couple of things I wanted to say.
Oh, we're doing D? We did.
Leads me to a couple of things I want to say, which was the positives and negatives. I can multiply by negative numbers. So, for instance, I am going to multiply this one by negative 3. And this one I'm going to multiply by 2. Which is not what I know Matto did, but that's fine. I've just found a lower number that they both go to. Oh. So number 1 goes to 12x plus 18y equals 24. Now number 2 goes to 12x
plus 18.
Negative 3 times negative 4 is positive 12. Negative 3 times negative 6 is plus 18y. Negative 8 times negative 3 is positive 24.
They're the same.
Right, so what do I do if I get this stage?
Same line.
Right.
The same line, right? I can stop at that point and we can say there are no unique solutions because
They're
the same line. Okay, so that's an interesting one. That's why we talked about the one to start with. In elimination method, do you think it was quicker to spot it?
Definitely.
Right, in this case. When we did substitution method, we basically got all the way to the end and went, that doesn't make any sense, Sammy. So, you know, what we got here. Quicker.
We did
Like the other one I just want to talk about is the one I was just chatting to with Nico, which is not massively difficult, but it does have an extra step, which is you will notice that the x's and y, the form of it is not the same when we start, but we can sort that out. So all I would do is in number 1, I would add 11 first. So my new number 1 now becomes 3x minus y equals 11. Number 2, I haven't done anything yet, is x plus 2y equals 6. Now they are in the same form. So you will often see that as a thing as well, where you have to do, just like with substitution, you have to do a little bit of rearrangement first. And in that one, you might go, well, to be honest, I could just add y and make it y equals and do a substitution method. Do you spot that one with this one as well?
Yeah.
If I just added y, my
Yeah,
number
just-
1 would have been 3x minus 11 equals y, and number 2 would be x plus 2y equals 6. I would just do a substitution method
They're
for that
both
one.
easy to substitute.
Alright, now either of those, not a problem, right? I would just multiply this one by 3 and carry on, or I would substitute. So my final question to you is, why use one method over rather than the other?
Because it's quicker.
Whichever one works best for you.
Why? When would that situation come about? Dave, you had your hand up. No, Sammy.
I would use the substitution method when there's only like one single x or one single y, and then I would use the elimination method when there's like 4y minus 2x and no like single x.
Exactly. I think that is a very good way of thinking about it. The ones we've done with the ones we've done with elimination method, it's because look, if I were to rewrite one of those as y equals or x equals,
You'd have a lot
I
of
am going to
fractions.
end up with fractions, right? Now, when I did elimination methods, this first example, I still ended up with a fraction as the answer, but I
that's
didn't
only
have it in
fraction.
the question. All right. Whereas if I used the substitution method, I would have ended up with a fraction to deal with that. All right. So if we look at the list of questions, which method?
Elimination. Elimination. Substitution.
Elimination.
Substitution.
Right. Now, some of you would just go, I'm just going to use elimination all the time. Right? And that is entirely up to you. In your exam, there will be a question that says, solve this using an appropriate algebraic method. If you choose to use an elimination method and it takes you an extra 3 minutes compared to a substitution method, get the right answer, doesn't matter apart from the fact that you used 3 minutes longer and you might not have got to some other questions. That's the reason why there's a time limit in our exam system, is because people that use the most efficient method also get better grades. So it's not just use whatever method you like to come out with the right answer. You're also assessed on your ability to use the most efficient, least amount of time method. All right? But obviously, doing it quickly, getting it wrong, I'd rather do it longer and get it right. Okay? So you use whichever method is appropriate. But yes, you should be able to look at each one of those and go, this one I'm going to use elimination. It's nice and easy to use elimination. This one I'm going to use substitution because it's easy.
Have you ever seen a million x's in one equation?
Yeah.
A million what?
X's.
But 5 billion Ys.
Oh.
Yeah.
So it's a ratio.
Right. So
Ratio.
we are done.